Alright, for this question we're going to use a little bit different area of the calculator than we've used before. We need to recreate this table. So that's the first thing I want to do. Alright, so I'm going to go into second matrix. Alright, and matrix is right above the x to the -1. I'm going to go edit matrix A. Let me slide this up a little bit. Alright, so matrix A is going to be 2 rows and 2 columns. So I changed the dimensions to 2 by 2. And now I enter these values, 449, 250, 251, and 50. Alright, so I've got my, my values entered in my matrix. Alright, so let me get back out. So now let me talk a little bit about the problem now that I've got those entered in here. What we're trying to prove here is that we have this gender of the interviewer, man or woman, and then women who agree and the women who disagree. What you typically are trying to find here is there some different treatment here? One of the ones that's on the test, the proctored test, is there discrimination between people that are white and people that are minorities on taking some kind of a test? And so you basically look at the people who pass-fail that are white and the people who pass-fail that are minorities, and you find out that there is some difference. There is not some difference based off your calculations, and you have to make an evaluation and answer these type questions based off that scenario. So there's two things that change this way, and there's two things that change this way. And for this reason, they call this thing a two-way table. All right. So does it appear that the gender of the interviewer affected the responses of women? All right. So if a woman was asking the question, 250 women agreed and 50 disagreed. But if a man was interviewing, it looks like it's almost twice as many agree as disagree, but almost 5 times as many agree than disagree if it was a woman. So just looking at that, you ought to say, yeah, there's got to be something going on here. Why is it when a woman asks the question, 5 times as many women agree, but when a man asks it, only 2 times as many women agree? All right, so now that we've got our data entered, let's go calculate this now. All right, so we're going to do a stat. We're going to go over to test, and we're going to do a chi-squared test. We're going to have to go way down. All right, there's chi-squared. All right, our observed is already in matrix A. Our expected, it will calculate that for us. So we just leave that alone. We don't have to enter matrix B. If you look in the book, you do need to actually calculate the second matrix B if you're doing this by hand. With this calculator, it figures out B for you. And all you have to do is hit calculate, and you get your test statistic is 36.758. Right, that's the number that goes here. Let me get back to that. Sorry, just a minute. So the test statistic, this chi-squared value is 36.7575, so 36.758, and then find the critical values. All right, the critical values is where we're going to have to look up a table. All right, so let me go find that. All right, so I'm just going to thumb through the chi-square distribution table here. We first need to find out our degrees of freedom, so I want to actually show you this table. If you scroll all the way down, of course, this is part of your notes formula sheet that you can take in. The degrees of freedom is the number of rows minus 1 times the number of columns minus 1. We had 2 rows, 2 columns, so 2 minus 1 is 1, 2 minus 1 is 1, 1 times 1 is 1. So our degrees of freedom is going to be on row 1. All right, so I'll go back up here on row 1, and we're looking at area to the right of the critical value, and if you remember in our problem, it said a 0.05 significance level. So we go degrees of freedom 1, 0.05, the critical value is 3.841. All right, so that's why that answer is 3.841. And so in this case, we reject the null hypothesis because there is sufficient evidence to warrant rejection of the claim, and it does appear that the gender of the interview affected the responses of women, because in this case, for a chi-squared test, what you have to do is you check to see, is it greater than this number down here? And it's far and away greater. You can see it only needed to be 3.8, and it was 36.7, so it's very, very clear evidence that, as we spoke, that for some reason twice as many women said yes compared to 5 times as many when it was a woman asking.